In this video, we'll show an example of an inverse trigonometric substitution, and we start off by recognizing the pattern. Square root of x minus 36 suggests the following substitution. So x is equal to 6 secant theta, and here we'd have to assume that theta is between negative pi over 2 and pi over 2. Now dx will be 6 secant theta tangent theta d theta, and the reason why we doing this substitution is because square root of x squared minus 36 will become 6 tangent theta. Now at the end we would have to go back to the original variable, and because of that we would like to construct this triangle that can help us figure out all the trigonometric functions of angle theta. So I label theta this angle, and then because secant theta is equal to x over 6, I label my hypotenuse x and adjacent side 6. So by Pythagorean theorem, the third side will be square root of x squared minus 36, and we're ready for the substitution. The integral now becomes 6 tangent theta divided by x, which is 6 secant theta, times dx, which is 6 secant theta tangent theta d theta, and we can simplify quite a bit here. So 6 secant theta cancels, 6 can be factored outside of the integral, so we have 6 tangent squared theta d theta, and this integral can be done by applying trigonometric identity and rewriting tangent squared theta as secant squared theta minus 1 d theta, and we get 6, and the derivative of secant squared theta is tangent theta, and antiderivative of 1 is just 6 theta and plus c. And now we have to go back to the original variable x, and using the triangle we can easily conclude that tangent theta is equal to the opposite over adjacent, so square root of x squared minus 36 over 6, and we get minus here 6 theta, and theta will be secant inverse of x over 6, of course, plus c. And now simplifying it a little bit, we get square root of x squared minus 36 minus 6 secant inverse of x over 6 plus c.